I'm Nerd Boy, as you know already, and today's topic is energy. Let's go! Hi, today I'll be Nerd Boy's assistant. I'm back! How did you do that? Well, I used a teleporter. Cool, huh? Let's go to my study. Woo! Ouch!
Hi, I'm Alice, Nerd Boy's accomplice. He. Now let's get on with energy. Come on.
Turn to page 210 of your science book, class! To be precise, read your science book and turn to page 210. Whoops! Potential and kinetic energy. Let's read the page. You read science. Have you ever gone skiing? Imagine standing on your skis at the top of a slope. You take a deep breath and push off with your ski poles. At first, you move slowly. Then you gain speed, gliding faster and faster over the snow until you reach the bottom of the hill. This motion takes energy, but you are not supplying it. Where does the energy come from? Energy is the ability to cause change in matter. There are two forms of energy. Potential energy is stored energy that is due to the position or condition of an object. You have a lot of potential energy when you are at the top of the hill on your skis. As you begin to ski down the hill, potential energy changes into kinetic energy, the energy of motion. The amount of potential energy an object has depends on its position and its mass. A thick layer of snow at the top of a mountain has a huge amount of potential energy because it is so high. If that snow mass begins to slide down the mountain in an avalanche, its potential energy changes into kinetic energy. The faster the snow moves downhill, the more kinetic energy it has. The moving snow has so much potential energy that it can destroy buildings and trees in its path. You know that you need energy in order to live and do the things you need to do each day. You get your energy by eating food. Food contains chemical energy that your body uses to keep you moving and growing. From food, you get energy to study, read, play, ride a bicycle, or clean your room. Scientists define work as the result of a force causing an object to move in the direction in which the force is applied. How do the things you do fit that definition? You are definitely doing work when you are playing, writing, and cleaning. In doing these things, you are using kinetic energy to cause force that results in the movement of matter. Suppose you play soccer or kickball. It takes energy for you to kick the ball with enough force to move it towards the goal or the outfield. The force moves the ball in the direction in which you kicked it. The ball has kinetic energy, and you did work on the ball. Turn the page. Waves. Think of the last time you went swimming. It might have been in a swimming pool, in a lake, or in the ocean. Did you observe waves when you were swimming? Were they large or small? What exactly are waves? A wave is a disturbance that carries energy or matter through matter or space. It is important to remember that a wave carries only energy through matter. A wave does not carry matter. Think about the waves you made in the investigate. Not. You started each wave by moving the spring toy in some way. You watched the wave move along the spring. After the wave had passed, though, you could see that the spring was in the same place by observing the position of the yarn tied to it. Waves are moving along a spring or spreading out in water are mechanical waves. A mechanical wave needs matter for it to travel from one place to another. Earthquake waves are also mechanical waves. If you look carefully at many mechanical waves, you can see that they have two parts. The first part is higher than the part behind it. The high part of the wave is called the crest. The low part is called the trough. Study the picture. A complete wave is made up of one crest and one trough. The distance from the middle of the crest of one wave to the middle of the next crest is called a wavelength. When you made waves in the spring toy knot, you displaced or moved the spring from its resting position. The distance that matter in a wave is displaced from its resting place is called amplitude. The amplitude is the distance from the resting position to either the top of the crest. Well, now I will explain potential energy and kinetic energy and waves using a contraption thingy, or a marble slide, as you call it. This marble sitting on the top of the slope is an example of potential energy. This is because the marble is like stored energy. When the marble goes down the slope, the motion makes it kinetic energy, since kinetic energy is the motion energy. When the marble hits the bell, it makes a wave. It makes a wave a sound wave. This also reminds me of the two types of waves, as we'll explain them.
Sound waves. Sound waves are waves that carry sound. Use a guitar as an example. When you strum on the string, the sound waves push the air molecules. The push makes a compression or squeezing together. Electromagnetic waves. Electromagnetic waves are vibrating electric and magnetic fields that carry energy.
Electromagnetic waves include light waves and several other waves.
The small part of the spectrum that you can see is called visible light.
Other light waves have longer wavelengths and lower frequencies than visible light. Study the picture in the top right corner. Study it. What did you see? Explain it to your teachers. Well, until next time, bye.
Bye. Bye.
Bye.
Bye, bye,
Bye.
bye.
Bye. Bye. Bye. Bye. Bye.
Bye.